Hey everybody, this is Matt with mattsmath.com. Thanks for joining us here today as we talk about how to identify similar figures. We are in the Common Core Standard of Geometry, and we're going to be creating, describing shapes and figures. We're going to solve some real-world math problems today, including area, surface area, angles, and volume. All right, our guiding question before we get started is we're going to be able to ask ourselves, how can you be able to use similar figures to enhance your art? You ever thought about how math affects art? Well, today you are going to learn that distinction. Let's get into it. All right, here is a picture of my 4 kids, and we went out to a fun aquarium, and there's this giant sea turtle in there, and there's my youngest daughter reaching up there trying to grab him. Isn't he so cute? Well, if you've ever seen pictures that are maybe a little bit distorted, maybe look like they've been shrunk or enlarged abnormally, that is talking about similar figures and how those are not similar figures from their original picture. So we're going to take this picture and we're going to transform it. We're going to do a lot of things to it here in just a minute, all right? Let's do it. All right, when we look at a picture, we can see that it's different depending on the original one. If it's similar or if it's not similar, we can tell if it's distorted or not. Let's look at these two pictures. We have this picture here on the left, and this is the original picture. We have all the sides labeled. We've got the A on the bottom. We've got the B and angle C up here as a 90-degree angle. So this is a rectangle we're looking here. Isn't that a cute turtle? Tickle, tickle, tickle. All right, so what we can do here is we've shrunk now the picture, and it is similar. So C, angle C, is similar to C prime. And side B is similar to B prime up here, as well as A is similar to A prime over here on the side. Notice that they do correspond to the right sides. A is not similar to B, and B is not similar to A prime there. All right, we've rotated it and turned it. This may be called a portrait picture, and this is a landscape picture if you're familiar with photography. All right, so what happens here is we're going to talk now about similar figures. And this is a word that you're going to need to know. All right, so write it down. Similar figures. Similar figures, they have the same shape, but not necessarily the same size. So when you think about the two pictures we just looked at, they were the same shape, rotated differently, which doesn't matter, and different sizes. These are similar figures. They're not distorted, and they don't look abnormally different from one another. And one of the things about this is that they have corresponding angles and sides. So the sides match each other, and the angles match each other. They line up. Remember that I said A was to A prime and B was to B prime. A didn't go with B and so forth. All right, and the thing that we're going to see here is that A is equal to A prime. Now notice with these little squiggly lines, these are fun to do, A is proportional to A prime. That's what this little line means here, is proportional. A is proportional to A prime, B is proportional to B prime, and angle C is actually equal to angle C prime. If you think about the picture again, let's go back. If we were to set up a proportion, A would be proportional to A prime, B to B prime, and so forth, okay? And the angles of similar figures are actually equal. So you take angle C, it's equal to angle C prime. So if we're going to write an equation real quick about this, what we would do is we would put A on top, A prime on bottom, equals B over B prime. So that is our proportion that we can use to set up. So let's do solving some problems here and look at how art might be affected by figures that are not similar. So notice in like maybe particular drawing programs that you look at, you might notice that you've got these little squares there, and usually, or they might be in the corners too. Usually what that means is you can stretch it vertically or stretch it horizontally, and a lot of times when you stretch it, they don't look similarly to the original picture. My kids are not this tall, and you can tell that that turtle just looks weird, doesn't it? And my kids are definitely not this wide. So, and this turtle, look how skinny and long he is. So this is a huge difference. When you take something and distort it, It is not similar. And that really affects your art. It really affects the pictures that you might be taking or stretching or modifying with some sort of drawing program on your computer. All right, so what we're going to do first now is talk about naming these corresponding sides. All right, let's name the corresponding sides. Notice it's rotated. The smaller figure over here is rotated from this figure. And we're going to rotate it 90 degrees clockwise. So AB corresponds to GH. BC corresponds to HE. Notice I'm saying them in order, A to B, G to H, not A, B, H, G. Okay? And then D to C corresponds to FE. Or we could say CD corresponds to EF. And then all the angles are the same. So we could say angle A is equal to angle G, angle B is equal to angle H, D to F, and C to E, and so forth. And this is how we're going to write it. AB is proportional to GH, BC is proportional to HE, angle A congruent to angle G, and so forth. Okay? That's how we're going to write it. If you've not ever seen this symbol before, that means angle. So the angle at point A is equal to the angle at point G. All right? We're good to go. Let's do it. So would you now name these corresponding sides and angles? All right, you ready? Now notice my answers when we look at them here in just a second. They might be different than yours. What I did to take the triangle to make it similar is I took this point and I flipped the triangle up this way. So just imagine sitting tight here on M and N, taking L and flopping it up here. So that way L is congruent to X, M is to Y, and N is to Z. So if you took it and rotated it this way maybe a little bit and put M on top, no big deal, same thing. So M can be congruent to X, L can be congruent to Y, and N to Z. And we can do that because these are equilateral triangles. All right, so here are my answers. All right, now what we're going to do is we're going to set up proportions. Using these shapes, if they're similar, we're going to talk about how their sides are proportionate to each other. So they will be similar if their sides are proportionate. So let's look at this guy. We've got a triangle here that's 3, 4, 5, and then this one over here is x, 20, and 25. Are they proportional? That's what we're going to figure out. From the beginning, I'm actually going to tell you these are proportional. And we'll look at it and it'll set up in a specific way. So I remember I take the corresponding sides, so 5 is congruent to 25. So I just write it as a fraction, 5 over 25. It's a proportion. They are similar, so their sides are proportional. And we put 4 over 20. Do these reduce to the same? What's 5 over 25? Well, that's 1/5. What's 4 over 20? Well, that's 1/5, right? Now, so to find these sides a different way, we can compare 3 to 4. We can compare 3 to 4. So let's do that. We can do 5 to 25, or we could do 5 to 4, 5 to 3. We can compare any of the sides, as long as we stick with the corresponding sides or the sides here. So let's do that. So we've got 3 is compared to 4, and x is compared to 20. I stick with the same sides. So notice 3 and x here are the same sides on the different triangles, and 4 and 20 are over there on the corresponding sides of the different triangles. So this is a proportion. You know what to do. Cross multiply, divide. Maybe even figure out how do you go from 4 to 20. Multiply by 5. Bam, there you go. What's the length of side x? I think you got the idea. All right, why don't you do it for these ones? Are these figures similar? How do you go from 5 to 9? Is it the same way from 8 to 12? If these figures are similar, their sides will be proportional to each other. You set them up equal to proportion, you cross multiply, and if those numbers are the same, bam, you're good to go. Are they similar? All right, what about these guys? Notice this one's rotated. So the 5 corresponds to the 10, and the 2 corresponds to the 4. So how do you go from 2 to 4? Is it the same by going from 5 to 10? Now you can answer whether these are similar or not. So the first one wasn't, because it wasn't by the same factor there, and the second one was, because you just multiplied it by 2. All right, In your classroom, a dry erase board is 8 feet long and 4 feet wide. Your teacher makes an individual dry erase boards for you to use at your desk. They are 11.5 by 9.5 inches wide. Are these boards similar? Have any idea? We'll set up a proportion just like what we did up here. Set them up. Always do the length to the length, so 8 to 11.5, and the width to the width, so 4 to 9.5. Set them up in a proportion, cross multiply, and are those numbers the same? If they are, bam, you got a proportion. And they're similar figures. What about this guy? You have a 4x6 photo of your friend, and you order a 5x7 print. Are they original? Is the original compared to the new one similar? Again, you're doing the same thing, setting up a proportion. You want to enlarge the photo 3 times its size on the computer. Is the new photo similar to the original? I'll give you a hint. Find the new dimensions of it being 3 times as large. All right, ready for the answers? Need some more help? Well, check these guys out. Here they are. First one was no, they are not proportional. And actually 2A, not proportional at all. And 2B is proportional because you're just multiplying both numbers by 3. So they are similar. If you only multiplied the length by 3, then they wouldn't be. All right. How'd you do? Can you answer this question about how similar figures enhance your art and how to solve proportions to get those proportions right? Just figure out if they're similar or not? I bet you can. All right, well, that was it as we talked about identifying similar figures today. This was Matt with mathsmath.com. Thanks again for joining us. Check us out on Facebook at Solving Maths Problems and on Twitter, Maths Math. And enjoy math.